Good morning, good afternoon, good evening. Welcome to Late Night Learning. I am your host, Dr. Anthony Palomba. Now today we're going to be talking about cluster analysis. A cluster analysis is a very useful analysis in marketing, in public relations, in advertising. It is related to segmentation studies, perhaps another phrase that you've heard. The idea behind a cluster analysis is to cluster people together. So we run a lot of different analytics in marketing, in communication, and we try sometimes to group people together. So it could be a survey, it could be a data matrix from which we're pulling out live actual data from movie ticket sales or whatever it might be. We might say to ourselves, well, it might make sense to group people around a set list of variables, traits that we agree are germane to composing a particular consumer profile. So we might say, well, we can group people by how often they watch movies on platforms, such as laptops and tablets and desktops and such. Or we can group people by the different genres they watch. And we can see different consumer profiles kind of come out of the woodwork. So in running a cluster analysis, we might say, oh, we have this particular consumer profile in which people who watch rom-coms tend to be women 18 to 34 years old. Oh, and they actually also tend to watch comedy as well. So by using sex, age, genre, frequency, consumption, and a few variables here, we're now creating different kinds of clusters. The goal of a cluster analysis is to piece together clusters that are represent or are emblematic of what's going on in a data matrix. Who are the kinds of people that took your survey, that are involved in your particular data set, if you will? So it could be, again, pulling data sets from social media or from TV viewing or from film viewing or whatever it may be. And so cluster analyses, once you have these consumer profiles, SPSS or any kind of software package that you're using, could be R, could be even Tableau, you're able to create these profiles by which you can then run further analyses. What variables then might predict the women who watch rom-coms who are 18 to 34 who also happen to watch comedy, right? Because now we can treat this as an outcome variable or as a dependent variable to then say, what else is going on here? What else can we use to help predict this, whatever this might be? And so as you can see, cluster analyses really bring a lot of information and a lot of insight into who we're targeting and who we should be targeting. Could very well be that a company might say, well, we're going after young males who play video games and watch action genre-based television, if you will. But if we run a cluster analysis from TV viewing data or from a survey on behalf of the company, we can perhaps see that if we measure or create clusters based around frequency of TV viewing, frequency of video gameplay, and sex, male, female, we might see that, in fact, we have different clusters. We might see there might be other people who are actually consuming our product or service. And so we might have to rethink as the company, should we be going after this demographic or this particular consumer profile anymore, or should we expand our advertising, public relations, and marketing communications toward other segments, toward other people who clearly are gravitating toward our product or service? So that's kind of an overview of what cluster analysis is. In this lecture, we're going to be delving into it. We're going to be talking about K-clusters, K-means clusters, and a few other tools to help us figure out how many clusters we need when an analysis has been executed. So let's get started. So what is a cluster analysis? Now, researchers often encounter situations best resolved by defining groups, of homogeneous objects, whether they are individuals or firms or behaviors. So again, I used people as an example, but typically we're looking to group things. Those of you who may have a science background, a biology background, you may think about taxonomies, and in fact, you would be right. We are thinking about ways in which to group and cluster. How do we group firm behavior? How do we group people behavior? We're able to do this through cluster analysis. So this same need occurs elsewhere. Particularly, we use cluster analyses when we're looking at people. That tends to be very, very popular. The goal is to maximize homogeneity of the objects within the clusters while also maximizing the heterogeneity between the clusters. If some of you are scratching your head and saying to yourself, this sounds very familiar, it should. This is very much familiar to factor analysis, which helps group variables together rather than people. And so with factor analysis, recall that we are aiming to create scales that help explain variance within a data matrix. And so this is also related to experiments and ANOVAs, right? We want the within group variance to be low, and we want the between group variance to be high. It's the same thing here. If we have cluster 1, it really should be all those women who watch rom-coms and are ages 18 to 34, right? We want all the people in that cluster to be the same, which is not something that us as people particularly care for. It's kind of weird to be grouped in with others. We like to think of ourselves as individuals. The goal of a cluster analysis is to really within it have that homogeneity. Everybody is the same. But then when we compare two clusters, there should be differences. There should be differences between cluster 1 and cluster 2, and it should be darn clear. Let's keep going. The goal of the cluster analysis is to create high internal within cluster homogeneity and high external between cluster heterogeneity. So the cluster variate, which is one cluster, it's a mathematical representation of the selected set of variables which compares object similarities. Again, this allows for taxonomy creation. Let's keep going. So what we can see here, like biology, cluster analysis seeks to separate group levels. It allows for better organization and further data analysis. Yes, once you've run a cluster analysis, particularly a two-step cluster analysis, you're able to create a new cluster variate. And so you can start running analyses with these clusters. And you can see here with an example here, we have a red fox, but we can divide up the red fox into either a kingdom or a phylum or a class or an order or family or genus or species. We know that there are far more species than genus, than family, than order, than class, etc., etc. So another hallmark of a cluster analysis is not only how many clusters may be born out of an analysis, but how granular do you want to get? You just want to separate clusters between male and female and platform usage? Okay. Or do you want to incorporate more variables which may very well lead to more clusters? If we do this, we'll have more clusters but less people. Is that good for our analysis? That's a decision we need to make as statisticians. Let's keep going. Cluster analysis goals. So data reduction. The goal here is to reduce data. This is also similar to the factor analysis lecture that we had earlier. You may have a large amount of observations or for people, which allows for classifying groups into manageable groups. That's the goal here. We want things manageable. Hypothesis generation. Cluster analysis is also useful when a researcher wishes to develop hypotheses concerning the nature of the data or to examine previously stated hypotheses. I recently ran cluster analyses for a study looking at how platform usage, lifestyles, and personalities of consumers could be used to develop really strong consumer segments that predict viewing behavior. relationship identification. By defining structure among the observations, cluster analysis also develops a simplified perspective by grouping observations for further analyses. Factor analysis attempts to provide dimensions or structure to variables. Cluster analysis performs the same task for observations. Hence, observations are viewed as members of a cluster. That's the difference, a key difference here. So we know typically that we might group people around or might group around variables, right? Brand personality traits of Netflix, brand personality traits of Hulu. There might be 20 or 30, and we want the 5 or 10 that really help explicate the data matrix. And so here, again, we're also looking at relationships between the clusters that might be defined here. Let's keep going. A researcher may believe that attitudes toward diet versus regular soft drink consumers could be used to separate people into groups. So that's another way of doing this. Cluster analysis can classify soft drink consumers by their attitudes about diet versus regular soft drinks. And the resulting clusters, if any, can be profiled. So this is something else to consider. How do you want to group people? That's something everybody should be writing down right now. Just a big giant question in your notebook or however you're taking notes here. How do you want to classify people? Recall our lecture around factor analysis. Garbage in, garbage out, ladies and gentlemen. A cluster analysis will always run. So you can run a cluster analysis all you want, but if you're not putting in the proper variables, or if there's no underlying logic affixed to the variables that you're including, then it doesn't matter that you ran a cluster analysis. Who cares? So you have to be very careful to employ really sound logic when you're going after this. Let's keep going. Cluster analysis continued. Cluster analysis may also work well, even too well. So again, as I reiterated earlier, garbage in, garbage out. You can throw any variables into a cluster analysis. It'll give you something. So you have to be careful here. The researcher is making an assumption of some structure among the objects. You're making an assumption about some of the objects here, how things cluster together. You're thinking about the relationships. Now, a cluster solution is not generalizable. It's absolutely dependent upon the variables used. So this criticism can be made against any kind of statistical technique. There are always limitations to generalizability, and so we know that it kind of varies from stat technique to stat technique. But the cluster analysis is generally considered more dependent on the measures used to characterize the objects than other multivariate techniques. Let's keep going. So the execution. Again, as we talked about in factor analysis, we're looking around pattern recognition. We're looking to see if there are patterns and groupings that we can rely on here. How do we know how many groups we form? There's an inherent trade-off here, and I alluded to this a little bit earlier. Fewer clusters and less homogeneity within clusters versus a larger number of clusters and more within group homogeneity. So that's the question here. How far do you want to go? As the number of clusters decreases, the heterogeneity within the clusters necessarily increases. If we have too many clusters, there really is no data reduction then, right? Because then we have 10, 15, 20 clusters with maybe 5, 10 people in each. We've made things too granular, a little bit too complicated. So ultimately, there must be a balance made between defining the most basic structure, fewer clusters, that still achieves an acceptable level of heterogeneity between the clusters. Let's keep going. Cluster solution. Now remember, we are trying to get the simplest structure possible that still represents homogeneous groupings, partitioning the data set to form clusters and selecting a cluster solution, interpreting the clusters to understand the characteristics of each cluster and develop a name or label that appropriately defines its nature, validating the results of the final cluster solution, determining its stability and generalizability, along with describing the characteristics of each cluster to explain how they may differ on relevant dimensions such as demographics. So you want to determine stability and generalizability once you have produced your clusters. And really one way to do it is to run your clusters as a linear regression. And so you can use the created clusters as a dependent variable, and then to see, does it make sense that certain other variables would be predictive of cluster membership, if you will. Let's keep going. So research design in cluster analysis, you want to be mindful of sample size adequacy. You want to be mindful of outliers, how they should be detected and if they should be deleted. How should object similarity be measured? Again, you want to think about how you might want to sort your clusters. So you can either determine that you want to sort your clusters across different kinds of race and ethnicity, income level, or the system may produce clusters with all of the variables considered. And then you want to think about, should the data be standardized as well? So these are some considerations that you should have here. Is the sample size adequate is a big one. Usually a good rule of thumb is that you should have about 30 participants, 40 participants per variable. It varies scholar to scholar, but those seem to be the best ways to go about creating your own cluster groupings. Let's keep going. So how should object similarity be measured? What will we base our cluster on? Again, these are questions that we've already hashed out, but it's important to be able to reiterate these. Can outliers be detected in our sample size? That's important. You may tick on the SPSS menu that you may want outliers detected, or you can run descriptives and frequencies and find your outliers if you have any, and delete them if you wish. How will we know what variables to include? Again, that's based on logic, it's based on market trends, it's based on underlying theory that you might be employing here, and also thinking about what's your objective. You know, running cluster analyses, running all of these multivariate stats are sexy, but you have to know what the next step is. You have to have some sort of idea of why you would run something and what it would do for you, for that matter. Let's keep going. K-means cluster. So there are a bunch of clusters out there. There's hierarchical clustering, there's two-step clustering, there's K-means clustering. Personally, I've used clustering less than other methods in particular, but when I've run clusters, I usually run K-means and two-step. I run those together because there is some literature out there that suggests that running two cluster analyses together or running a cluster analysis and a factor analysis together is just a nice way to check yourself and to make sure that the clusters are producing what they should be producing. And so this allows for quick clustering without steps attached to it. K-means is really good by that. It's based around creating clusters by distance, and I'm going to show you what that means in a second. Let's keep going. So we have 5 data points here. We can see that if we're thinking about clusters. Now K2, K equals 2, we're thinking about creating 2 different clusters. We have 3 red data points and we have 2 gray data points. Let's keep going. The centroid. So you'll notice in the last slide, we didn't have those X's on the screen. We just had data points. Centroids are means of the data points that are the X's. So what these X's represent are the averages. So if we look at the 3 red dots, don't worry about the gray stuff. If we look at the 3 red dots, that X is the average of those 3 data points. The gray X right here is the average of those 2 data points. And so the cluster analysis is starting to recognize means. This is good news. We want this. We want to make sure that our groups, our cluster groups, have averages. There has to be some sort of stability inherent within each cluster group. So the cluster analysis will recognize this and it will start finding the means. This is very, very important as the system is running. Let's keep going. Now, as you can see here, there's been a reassignment of each point to the closest centroid. So if we go back one slide, just look at what we have here. We had 3 red dots, right? 3 red dots and a red X. Let's go to the next slide. As you can see here, that last dot, that last data point is now gray. Why? Because it is closer to the gray centroid, the gray mean versus the red mean. And so this is what the cluster analysis literally does, just to give you a visualization. It is crucial that we ensure that all data points agglomerate onto a central mean, onto a centroid. This is a way in which to organize. And again, we are looking for great homogeneity within the gray dots and great heterogeneity between the red dots and the gray dots here. Let's keep going. So recomputing cluster centroids, as we can see here, we might change the mean. See what happened to the red X? Let's go back a slide. We can see here the red X is next to the gray X. But is the red X accurate? No. This is now an average between 2 data points. Let's go to the next slide. The red X is now between the 2 dots. The averages have been figured out. Now, this happens in a few seconds, mind you, ladies and gentlemen. This happens very, very quickly. This is not something that you can visualize. But in order to understand the process, to fully appreciate the SPSS output, it's important to get a visual sense of what's going on. Recomputing cluster centroids occurs, termination of the algorithm. Now we have different clusters. Now we have different clusters. And we have greater homogeneity within the group and greater heterogeneity in between the groups. Let's keep going. 2-step cluster analysis. I really do like these. It's a really, really great way to produce clusters. It also helps that it considers clusters based on categorical and continuous variables. So it's exploratory. Its objective is to unearth organic or natural groupings within a data set. So it's exploratory. That means it doesn't have any preconceived notions. There's no standards or parameters placed here. With k-means, you are able to set the amount of clusters that you may want. You might be able to do that with 2-step cluster analysis. I'd have to double check that. But here, we are able to use any kind of variable, which is really, really attractive. We have our 1 to 5 scaled variables, right? Ratio, interval, ordinal, and then categorical nominal variables, right? Our nominal variables are sex, gender, employment. It could be race and ethnicity, right? So we're able to use all of those things here. We can analyze large data sets here as well, and we can determine how many clusters we wish to produce here. Let's keep going. Hierarchical clustering. Okay, this is a lot here. We don't specify how many clusters we want here. It produces hierarchies of clusters. The 2 nearest clusters are merged to the same clusters here. In the end, there's 1 cluster. The number of clusters is determined by looking at the dendrogram. You may look at the number of vertical lines that go through individual clusters. And so here we can see that if we have 2 lines that go across this grouping here, we can see that each line, each red line, hits each cluster group only twice. So it makes sense here to hit it 4 times. So we can see here there's kind of a natural break, right? If we go up top, we can see that it is first split into 2 different clusters. Then it is split into 4 different clusters. Then it is split into 8 different clusters, and so on and so forth. So this is what a dendrogram will look like. What's important here is to be able to isolate when we think we have enough clusters. Again, this should be familiar to you regarding factor analysis, which is something that is similar to this. Let's keep going. Distance. So you'll hear about distance all the time with cluster analyses. You can leave the regular standards on in a cluster analysis. You don't really have to play around with this, but this is something that I wanted to go through with you. Usually Euclidean distance is what's used here. Remember when we were talking about those centroids and we had the red group and the gray group? Distance deals with the literal distance between each cluster, how we're determining this. You'll see these features on an SPSS menu. You can click on them. You don't have to click on them. It's really up to you. I recommend Euclidean distance. It's just a straight line between the clusters. That's how distance is determined here. Square or Euclidean or absolute Euclidean distance, pardon me. The sum of the square root, the squared Euclidean distance, has the advantage of not having to take the square root. City block distance, Manhattan, is not based on Euclidean distance. Instead, it uses the sum of the absolute differences of the variables. It's really up to you what you want to do here. City block could be useful if you want to take into consideration differences between variables. Euclidean distance is slightly different here. Let's keep going. Cluster analysis considerations. Two most important cluster analyses considerations: representativeness of the sample, potential multicollinearity among variables in the cluster variate. Cluster analysis is not an inferential technique in which parameters from a sample are assessed as representing a population. Remember, cluster analysis is used to quantify the structural characteristics of a set of observations. We're more interested in determining particular characteristics in a group rather than achieving a high level of generalizability. The requirements of normality, linearity, and homoscedasticity have little bearing here as a result. It is naturally a slightly more exploratory method regarding the cluster analysis, that is. Let's keep going. Cross-validation of cluster analysis. So, the most direct approach in this regard is to cluster analyze separate samples, comparing the cluster solutions and assessing the correspondence of the results. So the dendrogram was something that we looked at earlier. It provides that graphical portrayal of the clustering process. It is a tree-like structure that depicts each stage of the clustering process. Closer distances between combinations indicate greater homogeneity. And so we can see here with cluster analysis that there's quite a bit that goes on within a particular analysis. We have to think about variables, we have to think about dendrograms, we have to think about different kinds of variables that we might use in underlying theory and underlying logic and what we hope to get out of it. We also have to be mindful that it really is garbage in, garbage out with factor analysis as well as with cluster analysis. And so there are shared traits between both statistical techniques. It's really, really relevant to be mindful when you're running a cluster analysis to ensure that you have a next step. I can remember when I was running statistics for the first time, I would throw anything into it just to see what would happen. You can do that in an exploratory sense, but ultimately, if you're going to be creating customer profiles, you want to have a next step with that. Today, I don't think it's enough to create cluster profiles. I do think that you have to think about what's the next analysis that I want to use. Is there a hypothesis I'm interested in testing, or what have you, for that matter. That's all the time we have on Late Night Learning. As always, keep laughing and keep learning.